Okay, we got to composition. In this lecture, I'm going to talk about what is composition and what are its benefits. Then I will show you how to represent composition using UML notation. And finally, I will show you how to achieve that in code. So composition, just like inheritance, is another kind of relationship between two classes that allows one to contain the other. We refer to composition as has a relationship. For example, we can say car has an engine. Just like inheritance, with composition, we get code reuse. But composition is more flexible, and it's a means to designing loosely coupled applications, as we will learn later in the section. As an example, imagine we are designing an application, and as part of that, we need to have a class called dbMigrator that is responsible for migrating our database. This class will be responsible for creating new tables, populating them with data, maybe renaming columns, dropping columns, and stuff like that. As part of that, it requires some logging. Perhaps we need to log each step in the text file. Also, in our application, somewhere else, we could have another class called installer, which is going to be responsible for installing our application in a target environment. Just like dbMigrator, our installer also requires logging. So as you see, logging is something that is common between these two classes. What we can do in this case is to create a class called logger that is responsible for logging information to a text file. Here is a UML representation of this concept. So here, the logger class has the capability to log messages in a text file. dbMigrator and installer, they both have a relationship or association to the logger class. The type of relationship is composition, as indicated by black diamond on the left side of the relationship. In C# terms, composition is nothing new. So if you want to implement what you saw in the previous diagram, we simply create an installer class which has a private field called logger. In the constructor of the installer class, we get a logger object which we use to initialize that private field. So for composition, we don't have any special syntax like inheritance. The related class is simply a private field in the composite class. Now let's jump into code and see these concepts in action. Okay, we start by creating our logger class, which is where we have the common functionality. So I'm going to keep this class as simple as possible because what we want to learn in this section is about relationship or association between classes. We don't want to get distracted by details such as how to open a file, how to close it, how to write information to a file. So let's just leave that for now. So I'm just going to create a method called log that takes a message and simply writes that to the console. Now let's put this class in a separate file. So Alt and enter, back with Control and minus. We create a new class called dbMigrator. This class is going to be responsible for migrating our database. So we create a constructor, ctor tab, there you go. Now here we need a parameter of type logger. We want to create an association to the logger class. So logger. And now with ReSharper, I can put the cursor on this parameter here and simply press Alt and enter. And look, the first item is introduce and initialize field logger. So enter, it automatically created a private read-only field, as you see here, and initialized it using the argument passed in the constructor. Now let's say this class has a method like migrate. Public void migrate. And as part of migrating, which is going to be a complex task, we need to do some logging. So all we need to do is to call the log method of the logger class. So logger.log, we are migrating, blah, blah, blah. Now we put this in a separate file. We get back to program.cs using Control and minus. Let's create another class called installer, and we do the same technique there. So we create a constructor, ctor tab, create a parameter here, logger, Alt and enter again. There you go. We got the private field and create a method here called install. Again, as part of installing the application, we're going to log messages to our log file. So we simply call the log method of the logger class. So we are installing the application. Now let's put this in a separate file to clean up our code. Back to program.cs. Okay, now we create a DB migrator. For DB migrator equals new DB migrator. Here we need to pass a logger object. So one way to do it is just to create a logger object here, like new logger. Another way is to declare a variable and assign it to the new logger. And then we can pass that variable to the DB migrator's constructor. Let me show you this technique when creating a new installer. So var logger equals new logger. Now let's create an installer. Var installer equals new installer. So here again, we need to pass a logger object. So I'm just going to pass this logger object here. Now let's call dbmigrator.migrate and installer.install. We run the application. So here are the messages that are supposed to appear in our log. So the interesting thing here is we declared that common functionality, which was about logging, in a separate class here, and then we reused that in two other classes using composition. So as you have seen so far, we have two ways to reuse code. One is inheritance and one is composition. They both are valid approaches, but which one you use depends on the project you are working on and its requirements. Generally speaking, inheritance results in a more tightly coupled relationship. With composition, we can get loose coupling plus more flexibility. And that's the reason a lot of developers say favor composition over inheritance. In the next lecture, I will cover this concept in more details. I hope you enjoyed this lecture and thank you for watching.